Sentences. In mathematics, a sentence can be answered by true or false. Let's start with the opposite of a given statement. P can be true or false. The opposite of true is false, and the opposite of false is true. Next is conjunction, P and Q. A compound statement formed by joining two statements with a connector and. The possible truth values are true, true, false, false, and for Q, true, false, true, false. True and true is true. It is true when both of its combined parts are true, otherwise it is false. Next is disjunction, a compound statement formed by joining two statements with a connector or, P or Q. It is false if and only if both statements are false, otherwise it is true. Next is conditional statement, P implies Q. An if-then statement in which P is a hypothesis and Q is a conclusion. If the hypothesis is true and the conclusion is false, then it's false. It is defined to be true unless a true hypothesis leads to a false conclusion. By conditional statement, P if and only if Q. A combination of a conditional statement and its converse written in the if and only if form. It is true whenever both parts have the same truth value. Otherwise, it's false. A tautology is a statement that is always true. Example. Prove that the following sentences are true for all P and Q. Let's start with number 1. There are two sentences, P and Q, meaning there are 4 rows using the formula 2 to the power of n. The possible truth values are true, true, false, false. For Q, we have true, false, true, false. Be sure to capture every possibility of truth values that P and Q could have. If P is true, then the opposite is false. False. If false, then the opposite is true. True. For not Q, the opposite of true is false. The opposite of false is true. Opposite of true is false, and the opposite of false is true. For P implies Q, if the hypothesis is true and the conclusion is false, then it is false. The rest are true. The same thing for not Q implies not P. If the hypothesis is true and the conclusion is false, then the statement is false, and the rest are true. Now, is P implies Q if and only if not Q implies not P always true? For a biconditional statement, if both parts are true, then it is true. True, true, true. Therefore, the statement is true for all P and Q. Number 2. Let's write the truth values. True, true, false, false. For Q, true, false, true, false. For not P, not true is false, false, not false is true, true. For Q, just copy true, false, true, false. For P or Q, if both statements are false, then it's false. The rest are true. For the quantity P or Q and not P, if both parts are true, then it's true. The rest are false. Is this statement true for all P and Q? Let us see. In a conditional statement, if the hypothesis is true and the conclusion is false, then it is false. This is true, 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 and true. All are true. Therefore, the statement is true for all P and Q. In the next example, let us show that P or the quantity Q or R is congruent to the quantity P or Q or R. There are three sentences, P, Q, and R. The number of rows is 8. Let us write the truth values for P. True, 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 F, 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 F. For Q we have true, true, false, false, true, true, false, false. For R we have true, false, true, false, true, false, true, false. Here just copy P. Copy Q. Then R. Q or R. Remember that if both statements are false, then it's false. The rest are true. For P or the quantity Q or R, if both statements are false, then it's false. Otherwise, it's true. For P or Q, if both statements are false, then it's false. Otherwise, it's true. For the quantity P or Q or R, again, if both statements are false, then it's false. Otherwise, it's true. Now let's compare the result. Therefore, they are congruent.